Pointed up here at the front of the room. Is there something happening back there?
Yes.
And it's pointed, you can see the board.
Yep.
Don't care about being able to see my face.
Yeah, you can see the board.
Board, that's what I want. All right, you can see those numbers.
Yeah.
Okay. This is a pump problem because the point's going to be on the curve. All right, and I'm not going to try to confuse you later about whether it's a point off the curve or a point on the curve. But if I only tell you the x value, you agree you can put it in here and find the y value that is what? On the curve. So, yeah, it's got to be a punk. Point on curve. So let's write that, punk. Let's write it with a different pen. I'm not opening a new box of pens until I finish these off. All right, but I don't want to write the same color as that because I want you to be able to tell this is the work. Punk. Point on curve. All right. As soon as you see the words, find equation of tangent and normal line. Okay, tangent. We'll do the tangent. Don't even try to do them both at the same time. You write y equals x. Now, you might already realize that's going to be a minus 8 right there. I'm going to leave the blanks and I'm going to fill them in. Is everybody okay? That's going to be a minus 8. You're going to do fill in the blanks mathematics. You write out the tangent formula for a line, and you're going to put a minus 8 right there. Anybody got a question about how I got to minus 8? The x value is what? 8. So we know the point's going to be 8 comma something. In other words, what you have to have is you need a point and a what? Slope. That's the information you need. You need a point and a slope. That's what you got to find. And you already know the 8 value works, so what could you do? You could put the 8 in here and find what? Y. So let's find the point. Find point. Well, y equals cube root of 8 plus 1 over the cube root of 8. So y equals 2 plus 1/2, 5 halves. Don't you dare write a mixed number or a decimal. Do not write a mixed number or a decimal. All right, I just did the algebra of this problem. I knew an x value and I found the y value. Questions so far? I don't want to go too fast. That way I don't have to do a lot of teaching if I go slower. Right, now, let's talk about finding the slope. Hey, Mr. Evans, you told us how to find the slope last week because you gave us a formula that makes slope. Right? Makes a slope formula. Well, let's do the slope formula. And I'm going to do it, I shouldn't have written this part here because I really want to do the slope formula where? Right under there. So this isn't good because I'm about to erase something that's part of the problem. But if you've got that, you know how to do that. If you didn't know how to do that, you didn't make it to this class. Let's go ahead and get our slope. Slope. First thing you need to do is rewrite this with fractional exponents. Then you can apply the very first rule that we learned. I brought the 1/3 to the front, subtracted 1. Brought the negative 1/3 to the front, and I subtracted what? 1. Is that a good step? Now, I am not going to try to put the 8. You can put the 8 in here now if you want to, or you can rewrite it algebraically to make it easier to put the 8 in. All right, I'm going to put the 8 in right now. Now, when I do this, I'm going to write something that is not in the textbooks. I'm going to write something that a lot of people would probably not like to see. But I'm going to put M with a little 8 under it, right there. In other words, I'm writing that this is the slope, not everywhere, but just at what? X equals 8. Okay? And for some reason, I've just gotten attached to that notation. This means the slope of the tangent at what X value? 8. So I put the 8 in there. I'm even going to write a step showing you that I put the 8 in there. All right. So the slope at 8. Cube root 8 is 2. 2 squared is 4. Always do the root part first. Don't square it first. You make the numbers too big. Cube root 8 is what? 2. 2 squared is 4. And it's negative, so it's going to be 1/3 times 1/4 minus 1/3. Take the cube root of 8 first. You get how much? 2. And 2 to the 4th is 16. That's 1/16. Ladies and gentlemen, last year during the first exam, a young man sat on the back row, had a fit because he had 8 to the 4/3 and he couldn't ever figure out how to get it to a number. Because he did 8 to the 4th power, and he said, well, I'm going to have a calculator to do the cube root of that. I said, well, you didn't listen in class. Always do the what first? Do the root first. Do the root first. Now, so the slope, and someone says, Mr. Evans, you might, m of 8 equals 1/12 minus 1/48. Get a common denominator, and I think you get 3/48. No, I'm not going to teach you how to add and subtract fractions. And that reduces to 1/16. Yeah, so the m at 8 is equal to 1/16. And there's the equation of your tangent line. Notice that the part of this that's new to you is easier than all the rest of the algebra. Okay. Who's got a question? Anyone? Question? I'll try to answer. Now, how do you write the equation of the normal line? What is true about a normal and a tangent? What's the wording about that? Someone?
Aren't they perpendicular?
They're perpendicular at the point of tangency. That's right. Normal lines and tangent lines are perpendicular at the point of tangency. All right? You got to be careful. Make sure you know that this is occurring where? At the point that they are tangent. So this one is going to be real easy to write. And what am I going to put for the slope? -16. Y'all let this one man in the center of the room answer all the questions for you. Not good. And there's your normal. And we're not going to graph it and show that the graph looks reasonable and all of that. We're just going to have that problem. All right. I'm not going to erase for just a moment. Taking my time, making sure you're happy. Everybody happy? Okay, start at the top of a new page because this problem's going to be a little bit tougher. All right, here we go. to look at now is the idea that we know a point and we need to get from that point to the tangent line. Points not on the curve. I'm going to talk about a Pofc situation. And I'm not going to try to make one of these up, because if I make it up, it never turns out very nice. Here's a Pofc. This is what I'm here to teach today, right here. Pofc. Point off the curve. Now, and here's how the problem reads. It says, I don't want to write this whole problem, but I will. Find an equation of each of the lines through through 413. Wait, whoa, I'm not working that one. Through 2, -4. That is tangent to the curve y equals x squared plus 1. Now, first thing is this came out of the Lighthole book. Okay, this is the Lighthole book, all right? And this is the book that if you have someone in your family that became an engineer in the late 60s, 70s, or early 80s, this is the book that they were using. All right? This is the man, and this is probably what I'm going to teach out of most of this year. Yeah, I wanted to teach out of Stewart. He's a little too modern for me. We're going old school. All right. No pictures, no fancy drawings, just math. Okay. Now, here was my problem. Find an equation of each of the lines. Okay, that's a prepositional phrase, right? So it's find an equation. So equation, it should be you find an equation. Y'all, the U's implied, right? But I always thought this should be R. This should be plural. That is tangent, right? And I had a hard time because I think find an equation of each of the lines through that are tangent, but is. And I can't remember. I had to have an English teacher tell me that is right. I should have known Lighthole was right, but see, I kept thinking lines was see, that would be plural, right? And then you'd have an R here, but lines is not the subject. Lines is the object of that preposition.
Could be equation.
Yeah, there you go. An equation is what? Singular, right? So the is needs to be singular. There you go. Man, see, I knew there was something about that, but I had a problem. Okay, let's look at the graph. Let's talk about the graph before we get started. I might do the work over there. But let's look at the graph and see if I can explain what's going on here. Okay, there's the graph. Well, I got it written right above here. Y equals x squared plus 1. And 2, -4 is a point somewhere down here. 2, -4. Now, let me see if we can explain what's happening. It's saying that the tangent line is going to go through that point, and it's going to end up being tangent with that graph. So it's going to go through that point, and it's going to touch that graph up here and be tangent. Is that okay? It's going to go through that point and be tangent. Now, the reason it says of each of the lines is because there's also one where? Back there. See that? Okay. Is that all right? Now, I'm not going to try to work it for both of them. I'm just going to try to work it for one of them. I'm going to try to work it for this one right up here. Can't believe I've got another problem where I want to erase. You've got the problem written down, right? Here we go. So, and we know there's two of them, but don't try to find two of them at this point. Just try to find one. And here's why you've got to find this point. Because the formula that you have, y equals x squared plus 1, if you want to change it to your slope formula, dy over dx equals 2x. If you put that 2 in there and you tell me the slope is 4, the slope is 4 at x equals 2 that's on the curve. See, this formula only works if these x values are on the curve. So if you put 2 in there and you find out the slope is 4, that's not the slope of the line that goes up here and touches there. That's the slope of the line that's at 2, 5 right here. Everybody understand that? So that's your problem. What you've got to do is you've got to be able to work out a situation where this line is coming up here and it's touching that curve right there. But you can't put 2 into this formula because this formula only works if the 2 are where? On the curve. So, you got to step up. Now, I know the slope of this tangent line is 2x, but the x value has to be what? On the curve. All right? But I don't know the x value on the curve, do I? Now, if you look at this, you see this line? If you were to find its algebra slope, you would just go y minus -4 over x minus 2. And that would be the algebra slope for that line at this xy value. And this is our instantaneous slope of that line at that x value. Okay? So we've got instantaneous slope, we've got algebra slope, as long as we're talking about this x and y value, which is where? On the curve. Well, what's true about this slope of a tangent line formula and the algebra slope formula for this x value? They must be equal. So 2x has to equal y plus 4 over x minus 2. You've got the tangent slope and you got the algebra slope. And I'm going to go ahead and just tell you this is the calculus slope. Okay, let's just call it the calculus slope. Mr. Won't like that, and I'm going to do that. Calculus slope equals algebra slope. That is the key to working the Pofc problems. And I've told you why it's the key. You know, in the textbook, it might say, you know, make sure the algebra slope and the calculus slope or the derivative are the same, because I'm going to go ahead and start using that word for a second. Now, the only problem is you got x's here and you got y's. You need just one variable, don't you? What am I going to do on the very next step? Someone tell me. What do I know about the y value if it's on that curve? What does the y value have to equal? x squared plus 1. Mr. Bradford. I'm going to give him an A and everybody else a B if you can't answer a question or two. All right? Man's doing the A work, everybody just hanging on with the B work. Yeah, you know that if the point's on the curve, this y value has to equal what? X squared plus 1. Okay? If it's on the curve, that has to equal what? X squared plus 1. So I put my x squared plus 1 plus 4, and I solve for x. And that will tell me the x value is where? On the curve. Then once I know the x value is on the curve, I can use this formula and I can find the other information. All right, so you know the point's off the curve. What are you going to do? Somebody else say it. You're going to set, Miss, tell me. Say the word.
Algebra slope.
Equals
Algebra slope.
algebra slope. Back row, both of you at the same time.
Calculus slope equals algebra slope.
All right, over here, hi. What did I know to do with the y?
You substituted the original equation.
What it equals, that's right. Now, I solved this. And I get x equals 5 and x equals -1. Somebody said, work the steps, Mr. Evans. Don't be mean and cruel. If you cannot factor trinomials, you see me sometime, you let me know, yeah, I'm going to yell and scream at you. But if you can't factor trinomials, you can't do anything we're going to be doing, folks. And you know, if you have to do that slip and slide method, you're too slow. If you have to do that grow a tree method, you're too slow. All right. Now, you get x equals -1 and x equals what? 5. Everybody realizes now that this is the 5 one that works, and the line that we're talking about coming back here is the what? -1. If you just try to find one of them, you'll find the other one. Now, what's the y value? If the x value is 5, what's the y value? Somebody besides Mr.
26.
26, yes ma'am. And since you know the y value is 5, can you tell me the slope now? 10, because the 5 is on, the x value is 5. And the x is now where? On the curve. So you can use this formula. Slope is 10. Now, -1. Far side over here. Yes, ma'am. If -1 is here, what is the y value? Put the -1 in right here and you'll find your y value, right? So what do you get? 2. And what is the slope? Please realize that now you can use that formula to find the slope. Yes, ma'am. Keep talking. What's the slope? Use this formula. The -1's on the curve, right? You can -2. Do I really have to write out the equations for them if you know that information? Do I need to write? No. You got the information you need. I'm not writing out the equations. Y'all can do that. Fair enough? Not bad, right? Okay. Now, let's do another one. We're going to do one more. And I'm not going to write out the whole problem again. I'm just going to tell you what the equation is and what the point is. All right? I don't really want to erase this yet. I want to make sure everyone's okay with can't say that without thinking of a movie that y'all are probably too young to watch, but are we happy? We're happy. Now, same words as the last problem. We're just going to change the equation and the point. The equation is y equals 27 minus 2x squared. And the point is going to be 7, 1 this time. Now, so what's happening is you've got this curve. And I'm going to go ahead and make some drawing of it. It's down like this. Over 7, up 1. And I know it's outside the curve, all right? Because if it was inside the curve and you tried to work this, you'd find no solution. Because you can't make it tangent from inside here. If you drew it, you started looking at it. Now you could on a lot of them, but on this one you couldn't. All right. 7, 1. Now, you could say, well, I'm going to find the one that's way down here, but what would I do? I'd come back and do what? Try to find the one that's up here because I can see it. Is that okay? So I'm going to make a little tangent line. Touch it. Keep going. All right. The key to working this is to set two things equal to each other. What are we going to set equal to each other? The blank slope to the blank slope. The calculus slope equals the algebra slope. All right. Now I'm going to stop and let you write. You're going to write. I'm going to lean on my podium. Relax a moment. Let you write. See if you can write the beginnings of the problem.